What's going on, y'all? Today we are going to learn how to solve for the area of a sector. So for this, I want you to imagine that you are eating a pizza. So here is your pink pizza. And let's say this whole pizza is around, 2,000 calories. And let's say you were getting hungry, so you know what? You ate 5 slices of the pizza. So you ate 5 slices of pizza, and usually pizza comes in 8 slices. So what you want to find out is how many calories you just consumed. So what would you do? I think you and I both would know that you would take 2,000 and multiply it by 5/8. And from here, you would get 10,000 over 8. Plug that into your calculator, and you'll get 1250. So you will have consumed 1,250 calories. So obviously, it's not always going to be like this. And for general purposes, here's what we can kind of do to make this a bit more applicable to our class. So instead of saying how many calories there are in a pizza, we can say that this is the total area. So 2,000 is the total area of the circle. And 5 is going to be the degrees of the central angle. And 8 is going to be the degrees of a circle, which is always going to be 360. So as you notice, this is going to be remarkably similar to what we just did, arc length. Remember, arc length was equal to the circumference times the measure of the arc divided by 360. So it's remarkably similar. So the process is going to be the same. Let's go ahead and take a look at an example. We're just going to have 2 examples today. It's going to be quite short. All right, so we have a circle with area 18 pi. Find the area of a sector with central angle 40 degrees. So, with geometry, it's always good to kind of draw what's going on. So let's go ahead and draw something. Let's draw a circle. And it has an area of 18 pi. And we want a sector with angle 40. So this is 40 degrees. And we want to find the area of this sector. So here's what we're going to do. We're going to use our formula. The area times the central angle over 360. And this is going to be the area of the sector. So let's just go ahead and plug stuff in. We got 18 pi times the central angle, which is 40, over 360. And that's going to be equal to our answer. So now all we have to do is evaluate this. 40 over 360 is 1/9. And 18 pi times 1/9 is just going to be 2 pi. So the area of our sector is 2 pi. And usually we would have some units, but in this question we know. So the area of the sector is just 2 pi. Now let's go ahead and take a look at our second example. We have a circle of radius 5 centimeters. Let's go ahead and draw this. So here's our circle with radius 5 centimeters. And from here, we can go ahead and find the area of the whole circle. Remember, the area of a circle is equal to it's equal to pi r squared. So we just have to plug in the radius here, and we'll get, in our case, 5 squared, which is 25 pi. And yes, you'll have units, it's just centimeters squared. Find the area of the sector with a central angle of 300. So that's going to look something like this. A 300-degree angle is going to look very large. So it's going to be all of this stuff over here. So let's go ahead and figure this out. We got our area of a circle, 25 pi, times the angle of our central angle, which is 300 over 360. And this is going to be equal to the area of our sector. So now we just have to evaluate this. 300 divided by 360, that can reduce to 5 over 6. And this is 25 pi. So 25 times 5, that's going to be equal to 125 over 6 pi centimeters squared. And you can't reduce this, so we're just going to leave this in fraction form. If you were to put this into your calculator, you would get around 20.83 repeating centimeters squared. So both of these would be acceptable. And that's it for solving for the area of a sector.